The easiest differential equations to solve are first-order differential equations that are separable, meaning that we can put all the x's and dx on one side of the equation, all the y's and dy on the other side of the equation, and then just integrate both sides. So we call a first-order differential equation, again meaning we see the first derivative but not the second derivative, third derivative, etc. Separable if we can rewrite it as something like f of x dx equals g of y dy. So all the x's and the dx on one side, all the y's and the dy on the other side. And if we can, then we integrate both sides. And this process of separating the variables and integrating is called separation of variables. So for example, let's look at the equation y prime equals x squared e to the negative y. So this is the y prime is dy dx, and x squared e to the negative y is the same as x squared e to the y. And I guess we could multiply both sides by e to the y to put the e to the y over here, and then multiply by dx to put the dx over there, and we've got e to the y dy equals x squared dx. Alright, so this is separable. We've got all the y's over here, all the x's over there. So then we'll integrate both sides. So integrating, we have integral of e to the y equals integral of x squared, and those are both easy to integrate. So e to the y equals x cubed over 3 plus c. Now if we want to solve for y, we can take logs of both sides to get y on the left, and then log of x cubed over 3 plus c on the right hand side. So then we can ask which one of these solutions, so there's infinitely many solutions because we plug in all different real numbers for c, which one of these solutions passes through 0, 2? Typically in a differential equations problem, part A of the problem is find all possible solutions. Part B of the problem is find the solution that has this particular property. So here we found all possible solutions. Now we're going to find which solution passes through 0, 2. So to answer that, we'll solve. Let's see, our solution is y equals log x cubed over 3 plus c. So we'll plug in 0 for x and 2 for y. 2 equals log of 0 cubed over 3 is 0 plus c for c. So we solve that for c. We have 2 equals log of c taking the antilog of both sides, so that's e to the both sides, I guess we have c equals e squared. So the solution we want is, we'll plug in e squared for c, y equals log of x cubed over 3 plus e squared. Alright, now separation of variables is actually how I solved the differential equation that we looked at earlier. The differential equation is y prime equals 2y. And we can solve y prime equals 2y, or really y prime equals ky for any number k, by separation of variables. So this says that dy dx equals ky, which means that, so we can divide both sides by y, dy over y equals k dx. And we have to be slightly careful here, because when we divided both sides by y, we're accidentally throwing out the possibility that y could be 0. So when I do that, when I divide by something, I like to remind myself in parentheses, or y could have been 0. Okay, so now integrating both sides, the integral of, I'll write this down, integral of dy over y equals k integral of dx, means that we've got log of absolute value of y equals kx plus c. And that c is all real numbers. In fact, I sometimes like to write the c as capital R for all real numbers in these problems. Write that instead of c, and you'll see why in a second. So we've got an equation with x and y and no derivatives. It'd be nice to have the equation have the form y equals. So let me write that again up here. Log of absolute value of y equals kx plus all possible real numbers. So to solve for y when it's inside a log, we take antilogs of both sides. Antilog of both sides is e to the both sides. So e to the log of absolute value of y equals e to the kx plus all real numbers. E to the log of anything is just anything, so that's absolute value of y equals e to the kx, and I'm going to write this as e to the all real numbers. So e to the this plus that is e to the this times e to the that. Now what do we get? Oh, let's say or y equals 0. Let me just carry this around. So what do we get if we raise e to all possible real numbers? We get all positive real numbers. Because when we raise e to a power, whether it's positive or negative, the answer is definitely going to be positive. So that means that absolute value of y equals, I can replace this e to the all real numbers by all positive real numbers. Let me write that as r sub greater than 0, e to the kx. Or y equals 0. Alright, now we've got to get the y out of the absolute values. So if we remove absolute values from y, we have to put plus or minus on the other side. So that means that y equals plus or minus all possible real numbers times e to the kx, or y equals 0. Now positive numbers don't include 0, so it's anything greater than 0, and negative all real numbers is the negative numbers. But actually, if we include 0 in here as a possible constant, 0 times e to the kx is 0. So that'll take care of the y equals 0. So putting all this together, we really have y equals all positive real numbers e to the kx. And it seems to me in these separation of variables problems that when you have positive real numbers and negative real numbers and 0, it all sort of fits together at the end and you get all real numbers again. So, alright, so here's our solution. Y equals all real numbers e to the kx. So to summarize, all solutions of y prime equals kx are y equals c e to the kx for c some real number. Now often the independent variable x in a differential equation represents time. So it's interesting to know, or maybe easy to observe, what happens at time 0. So the question when we go to ask which solution has a certain property, usually it's which solution has a certain value at time 0. So which solution has, let's say, initial value y naught at time x equals 0. That's just another way of saying which solution passes through 0 y naught. To answer this, we'll just plug in 0 for x and y naught for y. Okay, so y naught equals c e to the k times 0 is just 0. E to the 0th is just 1. So that means y naught equals c. So that means that the solution we want is y equals y naught e to the kx. And this differential equation, which is so simple, and actually it's one of the most important differential equations, comes up so often, I think it's worth memorizing the solution rather than going through separation of variables every time. So if you have y prime equals ky, how did the x get in there? The differential equation is y prime equals ky. That comes up so often, you should memorize that the solution is y equals initial value e to the kx. So all you need to do to find this constant is know what the initial value is and just plug it in.